Hello everyone and welcome back to the next lecture of control systems. In this lecture, we will discuss the closed loop systems. In the previous lecture, we discussed about the open loop systems and we also had discussion on some of the disadvantages of using the open loop systems. And we all know that the open loop systems are not reliable because they are not able to handle the disturbance. So now in this lecture, we will try to overcome that disadvantage and let's see how we can do it. So let's get started. This is the block diagram of an open loop system that we have already discussed in the previous lecture, and we know that the open loop systems are internally divided into two different sections. One is the controller section, which controls the amount of input that is required for the desired output, and the process section processes the input in order to generate the output. But the major disadvantage in case of the open loop systems is that it does not know when to stop, or it is not able to handle the disturbance. We took one example of an immersion water heater in the previous lecture, and we know that if we put the heating rod inside the water and we turn the switch on, then the immersion water heater starts heating the water, but it does not know when to stop heating. Or we can say that open loop system does not know your desired output, and that's why it goes on heating the water until you turn the switch off. So in order to maintain the desired output, we need to measure the output continuously, and we do it by using a feedback signal. In the closed loop systems, we can say the output is measured continuously and is fed back to the input, where the error with respect to the desired output is determined. We call this unit as the error detection unit. And then after that, the signal goes to the controller. The controller then controls the amount of input according to the desired response, and then the controlled input goes to the process section, and hence we get the desired output. And this time the desired output is maintained. And in this way, the presence of feedback compensates for the disturbance and it improves the accuracy of the system. An air conditioner is a very good example of a closed loop system. It continuously monitors the temperature inside the room, and accordingly it turns off and starts over the compressor which is present outside the room, and in this way it maintains the desired temperature. We can have one more example of a geyser. A geyser is a water heater, but here we can set the desired temperature. It continuously monitors the temperature of the water present inside, and it turns off and starts over again in order to maintain the desired temperature. Whenever the desired temperature is achieved, the geyser will turn off. And after some time, when the temperature decreases, it starts over again in order to maintain the temperature. So now we are done with the introductory portion of closed loop systems, and now we will have a comparison of open loop systems and the closed loop systems. Moving on to the comparison between the open loop systems and the closed loop systems, we can say that the accuracy of open loop systems is low because they can't handle disturbance, whereas the accuracy of closed loop systems is high because they are able to handle disturbance. The open loop systems are not that reliable because they are not accurate. On the other hand, the closed loop systems are more reliable because they are more accurate. The open loop systems are easy to design because there is no feedback factor involved and the circuitry is simple. Whereas the closed loop systems are complex in design because an additional feedback factor is involved and the circuitry is complex. Due to all the three reasons, the open loop systems are less expensive as compared to the closed loop systems. But the closed loop systems are expensive. And now, what is the distinguishing factor between the two? Yes, it is the feedback which is the distinguishing factor between the open loop systems and the closed loop systems, and is absent in the open loop and is present in the closed loop systems. We will discuss the types of feedback in the upcoming sections of this course. We will also have the transfer function of a control system, but before that, in the very next lecture we will take a review of Laplace transform, because from now onwards the Laplace transform will play an important role in control systems. As of now, we are done with this lecture. I'll end this lecture here. See you in the next one.